about everything, not like the seasonal or regional. I'm talking about everything is gone. You melt the whole thing, and then it doesn't account for that. That's what I'm trying to say. Okay. So it appears the classical explanation of the latent Murray model of 66 is wrong, which I'm going to talk about next. Okay. Pressure can be derived by spectroscopy, supposedly. The European Space Agency sent a mission to do that, Mars Express Orbiter. Now the data is going to agree with the latent Murray data, the Viking curves, even though the pressure swings shouldn't be possible. But the technique will not work if you have ice clouds and frost, such as at both poles, and once again it ignores that you can't have those pressure swings. Next. Okay. On your left is the Mars Express Orbiter, European Space Agency mission, and on your right is the good old American Viking lander mission, Viking 1. Now, these curves look very similar. The one on the left is all an extrapolation based on CCM data. The X's there are data points taken by spectroscopy, only 9 of them. They seem to fit the curve well, but too well, and the curve on the right there is Viking 1. The amplitudes in the curve are a little bit different. That's because there's a couple 100-meter difference in height, and that counts for that. Now this my computer is really not working well. Okay. This Mars Express Orbiter actually carried a lander, Beagle 2. This was mentioned earlier in this morning. But Beagle 2 was lost. Now, supposedly for an unknown reason, it just disappeared. They couldn't find it. But if there were higher pressure, you would expect to lose the probe. There'd be many reasons for that. All right, next slide. Okay, that's the pressure spike I'm talking about earlier, the Mars Global Surveyor. You had a regional pressure at 75 miles, double in 2 days, and multiplied by a factor of 5.6 in 4 weeks. Now, if I took the 5.6 down to the lowest point at Mars, the Hellas Basin, which I know really isn't reasonable, but if you did that, you would get pressure. But I have other reasons for why I stated to some of you earlier that perhaps. Okay, next. Okay, Mars Reconnaissance Orbiter and the Navigation Chief Han Yu. That's why am I doing that? Okay, at some points in the atmosphere, we saw a difference in the atmospheric density by a factor of 1.3, which means they're 30% higher than the model. But around the South Pole, we saw an even larger scale factor of 4.5, which means it was 350% off the Mars Grand model. Now, you cannot use spectroscopy at the poles because of the ice. That is a problem. Next. Okay. Even though I presented all this information to you, Occam's razor, which states that the simplest solution is usually the correct one, would say that I should be wrong. I mean, because all the data pretty much agrees with itself, and I mean, you would have to have extraordinary incompetence, which I don't think would happen at NASA, or you would have to have someone fake the data. So let's just go with that one for now. All right, where'd it go? Where's it not going? Next. Yeah, I said next. Okay. Attempted humor perhaps here. You all know Buzz Aldrin's second man walk on the moon. If Occam were still alive today, he would say, I had an extraordinary reason to suspect disinformation. Did Buzz let the cat out of the bag? Now, on C-SPAN last summer, he said something very interesting. He said, visit the moon of Mars. There's a monolith there, a very unusual structure, and people find out about it. They'll say, who put that there, who put that there? Now, you could think he's letting the cat out of the bag or that he's misinformed. You decide. But now to the real point. Why should we really trash Occam's razor, and why should we trash all of the data? Okay, the weather does not match the low pressure values seen. Dust devils, dust storms, eye walls that look like hurricanes over our sea of Mons, where the pressure is going to be like 1/10,000 to 1,000th of what it is on Earth. Frontal systems in fog, even snow. I mean, plus the mariners were disagreeing with the scale height calculations for the minimum pressure on Mars by several 100%, not insignificant. Okay, the CO2 polls do not explain really what's happening yearly at the sites at Viking. There's no way to change any of these dust filters. Now, some of you may be wondering how we know the dust filter actually clogged. It was argued by Dr. J.E. Tillman of Viking Computer Facility, who I communicated with, that if these clogged, we would have problems with the annual pressure swings and the daily pressure swings. But we do. The yearly swings cannot be accounted for because there's just simply not enough CO2 ice to drive the cycle. Also, the data seems to be an exact repeat for over 4 years. Now, the daily pressure swings. The Vikings and the Mars Pathfinder were Tavis-built sensors. They said that the maximum pressure at Mars daily was at midnight and 10 o'clock in the morning. But Phoenix, which is a Vaisala instrument, stated that it's 8:30 and 15:30. That's about an 8-hour difference. That's considerable, and that might account for the daily problem. Also, the Phoenix transducer design had some problems. Our tower was at fault for some of them. Next one. Okay, the Mars Reconnaissance Orbiter encountered over 3 times more atmosphere than expected. The MGS had that huge pressure spike. The Phoenix and the Pathfinder wind data are both missing. No pressure sensors could measure higher pressure. They peaked out at 18 millibars. And NASA could not recreate the most common phenomena observed on Mars. It's about daily, really, if you look at Pathfinder. Dust devils at 10 millibar using the appropriate winds or even the appropriate technique. Next. Okay, if you want to read my report, which I gave you all, it has more discussion on this. Like, it might be better than I am when speaking. It also includes discussions about methane on Mars. It turns out there's 3 venting points. It's argued in a Krasnopolsky et al. Paper that it has to be biological in origin because Mars has been dead geologically for about 2 million years, and it can't be volcanic outgassing, and there's no chemistry to explain it. But you decide on that one. Also, I discussed caves in our Siamons and their implication for dust devils there. Perhaps some gases wafting up through that, and then that might help explain this. The Viking label experiment for life detection, which designed the test for life. Basically, you insert gases and stuff, and then the sample will either react or not react. The results were dismissed as null because of some peroxide issue. But revealed by spectroscopy, actually, recently, there are no peroxides on Mars, really, so that doesn't really make sense. Also, I discussed the potential pressure on Mars, even if I'm wrong. The estimates range in the future as Mars tilts naturally. It could be anywhere between 15 to 30 millibars or 800 millibars. Basically a wide range. My recommendations, which of course say send a sensor that can measure higher pressure, not one that can measure lower pressure like the MSL will, Mars Science Laboratory shown earlier. 11.5 millibars for that one. Next one, okay. Now, I'd like to think I'm a person. I've traveled around the world. One of my favorite places was Crater Lake, Oregon. It's a volcanic blast crater filled with rainwater. There's a little island in the middle, Wizard Island. I took a boat tour of the place. It took a couple hours. Now, on your, that'd be your right, on your right. There's an ice lake in Vestidas Borealis on Mars. Again, there's a little island there. There's snow around the edges of the crater like there is there. No trees, though. But it looks like that ice may have recently melted and refrozen because it has fit the shape of the lake. Now, interestingly enough, even if I'm wrong, you can have liquid water on the upper half of Mars today because the pressure is above the triple point, 6.1 millibars and 0 Celsius, or at least some of the time anyways. But it's not possible in the lower half if I'm wrong. But the point being, about higher pressure, you could have liquid water all over Mars, but then you might wonder, why don't we see it? Well, liquid water is not a very strong constituent in the atmosphere. It's locked in the poles. It's really dry in that way. But if we do have higher pressure, we should send a sensor that could measure it before we commit people there, because a lot of the probes that have been sent there, all of the probes for the Soviet Union, they all didn't work. One of them landed, worked for 15 seconds, then broke. No other nation except America has managed to put a lander on the surface of Mars. All have disappeared or crashed. So we should find out what the real pressure is, and then we should send people to Mars, as you all are here for. Thank you for your time. Any questions? Yeah. What?
You know, the carbon dioxide happens to be a heavy gas.
Yeah.
And, you might be getting some of that extra pressure, maybe the carbon dioxide covering the surface, and that would give you all your dust levels and give you higher pressure.
What I'm arguing here is not really that small of a difference that might make a very small difference. I'm arguing a lot larger.
Your craters and stuff,
you would have higher pressure at the bottom of the crater than the top, if that's what you mean.
What do you think about the bottom of Valmir on Earth? What do you think the millibars are on the bottom of Valmir?
Well, according to my scale height calculations, we'll say 12.5. That's if we accept NASA's data. I'd probably say like maybe 70 millibars. I mean, a lot of thunderstorms on Earth, actually, their tops can be about that elevation.
Yeah, that's
so
comparable to our atmosphere at 10 miles at the bottom of Valmir. I mean, 50,000 feet, because it's comparable to 100,000.
Yeah, but the real issue here, though, is...
that would be like another 10 miles.
The issue here is how do I fit the data, basically, to explain the dust levels at the top of our CMOs, where you should have 1 millibar. And to do that, I actually devised an experiment, which I haven't been able to get through yet, but basically you're going to create take a vacuum chamber, like NASA did, repeat their experiment, but with one change. You're going to up the pressure over and over again until you can form a dust devil at 6 meters in the minimum pressure on Mars. It could be higher than that, but I mean, that's the low end. Any other question? Yellow shirt, I guess.
I was curious. You mentioned that NASA attempted to recreate through atmospheric modeling the dust devils.
They actually did a real experiment.
Oh, this was an experiment.
This is a real experiment. They couldn't do it.
Well, my question is that if you're about these storms, maybe maintain higher pressure at the tops of the mountains. Wouldn't it be possible or sensible to do some detailed atmospheric modeling to finally ask how low the pressure can be to show you the morphology that's there? I mean, that would be something you could then check against. You don't know anybody who's attempted to do that computationally.
Can you like phrase it a little bit simpler? It's kind of long. I kind of lost you there for a second.
All right. An atmospheric model can predict the existence of a dust devil.
Right. Yeah.
But it's going to have to operate at some pressure. It's going to have to operate at some mix of the atmosphere. For air is different from CO2.
Yeah.
Temperatures and all that stuff. Take the atmospheric model and ask how low the pressure will be to see the kind of morphologies you see at the top of those mountains.
Yeah.
That's what I'm suggesting. Because anyone.
Yeah. I always thought the experimentation would be a better approach. I mean, that's more solid.
It's not just a matter of taste, because the experimentation has to know where to look.
Well,
computer model.
The experimentation just takes the typical result and then tries to simulate it. That's all it does.
The laboratory can't simulate the actual atmosphere because you're going to.
Oh, I think they could if you want to.
If it's actually the CO2 that's adding the extra pressure.
That's actually that's the molecular weight issue I mentioned earlier. They use the 10 millibars to account for that difference. So it should be roughly the same. In the back.
The experiment, did that take into account our gravity relative to Earth gravity?
Mars gravity.
There are other factors besides pressure that would be involved.
Right, but the issue being here is that no matter how fast they would spin the fan, they couldn't produce it at that pressure. You can do that at Earth atmospheric pressure quite easily.
There's another thing that we absolutely do not understand and have no ability to really duplicate in the laboratory, and that is the physical and mechanical and structural properties of the Mars soil particles. Some of them are mineral grains, but it's been long thought that many of the particles were dust aggregates or dust clumps. Phoenix demonstrated that with its microscopic instrument that a large fraction of the soil was aggregates of ochre-colored dust, submicron dust clumps. It is entirely possible that at the high altitudes of places like our CMOs, you might have ultra-low-density, electrostatically aggregated dust bunnies. We simply do not understand that soil. We did not understand lunar soil from the surveyor data, even though we had excellent images of what was going on. We didn't have the faintest idea of the formation of the glassic glutinates in lunar soil that stared at them in the first Apollo sample under a microscope. The Martian soil has gone through a profoundly different geological history and processing for billions of years onto the surface of the planet, and we don't understand how that soil behaves.
Yes, but we know the particle size for the dust lifting, so that's the key thing if you want to do a simulation.
I have another question. Did you present this to Jim Philman, the person?
No, I was actually in contact with him. I sent multiple emails back and forth. We were arguing about the dust filter issue.
Yeah, that's what I was going to ask.
Yeah, and that's how I got the...
Your papers on.
Okay, any other questions? Or? No, you in the back. The what? What do you mean? Have to do with what? With fine dust? Well, yeah, the soil is iron oxide. I mean, that's just rust. I mean, so, I mean, I don't think that would really have anything to do with it. I mean, the soil is the soil. I mean.
So basically what you're saying is that the next probe to Mars have a proper pressure sensor.
Yeah, that's what I'm arguing for. I'm not arguing for just a massive overhaul with blind faith. I'm just saying do this. It's not... I mean, well, all right, I guess that's it. All right. Good.